Welcome back to another week of COM 3073. In today's video, we're going to cover the topic of sampling in quantitative research. By sampling, I mean the process we go through to select objects or elements from a population of interest. By the end of the video, you should be able to tell me the relationship between populations and samples, why we often draw samples from populations, the differences between random and non-random sampling procedures, and common types of random sampling techniques. This module's video is shorter than previous ones because the information can be a little technical and similar to part 2, which focuses on non-random sampling methods. So let's get into the content of module 7. Here's a roadmap of where we're going today in order to provide you with some organization for your notes. First, we're going to talk about what a population is and its relationship to a sample. Next, we're going to discuss sampling, which is what we do when we pool limited numbers of objects from a larger set to use in our quantitative surveys, experiments, content analyses, and so on. Next, we're going to talk about the differences between two families of sampling techniques, random sampling and non-random sampling. Finally, we're going to talk in this video about different types of probability sampling, such as the simple random sampling and stratified random sampling procedure. And next time, we're going to focus on non-random sampling techniques, the most common of which is convenience sampling. Why is this discussion of sampling so important? Well, it provides researchers with guidelines on the kinds of strategies that exist out there to collect participants for their studies, and provides them with the advantages and disadvantages of each method. So let's get started. In research, our goal is to take a complete group of objects, whether those objects are people, animals, documents, or organizations, and draw a small sample or subset from it. This entire or complete group of objects is called a population. The reason why we draw samples from population instead of just conducting research on the entire population is that it's often not possible due to money, time, or reach limitations. By reach limitations, I mean that even if as a researcher we have loads of money and infinite time to complete our study, there would be certain groups difficult to get a hold of. For example, reaching or accessing the homeless or undocumented immigrants would be difficult, if not impossible, for recruitment purposes. Therefore, most of the time, we can't access all objects in a population for us to use an entire population. One important thing to keep in mind when thinking about populations is that the findings from the sample data are generalizable only to the population from which we sampled. That means great care must go into identifying the population. It also means that a population comes in many types and sizes. For instance, you could specify that the population of interest for your study is all humans. But in practice, to sample from all humans means that you would at least need to sample from people of all age groups, countries, sexes, and cultures. Likewise, you might just be interested in subpopulations for your study, subpopulations such as females only, college students, or even something as specific as just UTSA college students. Again, you can specify whatever you want as your population, but your results will be generalizable only to that population. One final thing. I keep mentioning that we are rarely ever able to conduct studies without sampling because we never have access to the entire population, but that isn't 100% true. In fact, I had a professor who used to study entire populations all the time. How? He used to study presidential speeches from certain time periods so he could easily look up the entire catalog of presidential speeches during, say, the 1940s to 1960s and do quantitative content analyses on them. Therefore, some populations are accessible to certain studies. This might give you a nice visual depiction of what we're doing in the sampling process in many of the communication studies involving human participants. During the sampling stage, we're pulling people either at random or in a purposive way into our sample. At the sample level, we collect data we need through one of our quantitative research methods and then use some kind of numerical analysis to run the specific kind of test on our data to see whether they support or fail to support our proposed hypotheses. The results or findings taken from our sample level data are then generalized back to the population. So if I'm interested in conducting a study on the relationship between number of telehealth appointments per year and satisfaction with one's primary healthcare physician, I can take a sample from a population, conduct a survey study collecting data, interpret that data and match them to specific hypotheses, and then generalize those findings back to the population from which I drew the sample. Just as a note of vocabulary clarity, the numerical analyses we run on the sample level data, whether it's a t-test, a correlation, an f-test, or even just means and standard deviations, are called statistics. When these statistics are conducted at the population level, which in many cases is just hypothetical, these numerical analyses are called parameters. The statistics we conduct at the sample level are trying to best estimate these parameters that exist at the population level. You might not notice it, but we sample from populations all the time, whether we're at the grocery store, choosing a restaurant for dinner, or picking a movie to watch on Netflix. Here's an example. Let's say that you're trying to plan a birthday party for your best friend and you were put in charge of getting cupcakes for the party. But which bakery do you choose? Well, of course, you probably are going to go to Yelp as your starting point and look for bakeries with the best ratings. Let's just say that the two standout bakeries on Yelp for cupcakes are Cakeland and Sugar Factory. You go to both locations and notice that they have a huge assortment of cupcakes. Surely you can't try all of the cupcakes from each bakery unless you want to end up with a very sore stomach. So what do? Well, you would likely choose or sample about 2 to 3 cupcakes from each bakery, take them home, test them, make a conclusion about which has better taste, textures, or decorations, and then generalize those results back to the bakery's other cupcakes. Here's an example of lay research using the concept of sampling from populations. Sampling in its simplest form is the process of selecting objects or events from a population. I mentioned previously that objects can be selected into a sample at random or in a more purposive way. Random sampling means that each person or element in the population pool has an equal chance of being selected into the sample. So if my sampling pool is a phone book and I randomly select participants out of that phone book, then this would be a case of random sampling. Non-random sampling is a little different. Non-random sampling means that each object or element is selected in a purposive way, such that each person in the population does not have an equal chance of being selected into the sample. Non-random sampling is usually less ideal than random sampling because certain characteristics might be overrepresented when selecting objects or elements in a purposive way. We'll get to that a little later when we talk about non-random sampling. We're first going to talk about specific random sampling methods and then move on to common non-random sampling methods. Please keep in mind that this list is not intended to be exhaustive. There are other sampling methods that exist out there, but these are the ones I want you to know specifically because they're used most commonly. The first random sampling method is called simple random sampling. Simple random sampling is the most basic approach to drawing a random sample of elements or objects from a population, as its name would suggest. In the process, elements or objects are selected into a sample using a FAIR process, such as a flip of a coin or a random number generator. So here's an example. Suppose I have an entire population of just 29 people. Let's just say it's a very, very remote, uncontacted tribe in the Amazon. The list of all 29 people is called your sampling frame. So, for example, if your sampling frame is all people with registered phone numbers in a certain geographical region, your sampling frame can be the White Pages phone book for that locale. The easiest way to conduct simple random sampling from this population would first be to assign a number to each person from 1 all the way to 29. Then, a researcher would turn to a random number generator that can easily be found on an internet site like random.org and input the parameters for the random number generator. In this case, the boundaries must be between 1 and 29. If the first number that's generated is 7, then you would select the participant assigned number 7. If the next number is 21, then you would select participant 21. And if the next number is 11, then you'd select participant number 11. You'd go through this process until you have as many participants as you need. Of course, you can scale this up as large as you need, even into the tens of thousands. Systematic random sampling is a process in which all members of a population are listed, and the researcher takes every nth person from that population until he or she has the desired number of participants. That explanation might be a little confusing, so let's go back to our sampling frame from the prior example. Let's say you needed to draw 7 people randomly from this population. In this example, we would first assign a unique identifier to each person from 1 through 29 like we did before. We would then choose a number from 1 through 4 at random and use that as our starting point. We would then choose every 4th person from that starting point until we reach our sample. Now you might be asking yourself, where did the number 4 come from? It's because there are 29 people in the sampling frame and you needed 7, so 29 divided by 7 is roughly 4. You know from there that we can take 1 out of every 4 people from the population to meet our desired 7 participants. This 1 to 4 elements we drew from our population is called the sampling ratio. So going back to our primary example, if we randomly selected the number 3 from the range of 1 through 4, we would select participant 3 and then every 4th person from there. By the time you get to the final participant, number 29, you should have selected 7 people at random. The next random sampling procedure we're going to discuss is stratified random sampling. In stratified random sampling, the researcher cares about creating representative samples based on some known proportion of the population. The researcher knows that he or she is sampling from a heterogeneous population comprised of different subgroups or strata. The subgroups might be different majors in college, such as communication students, psychology students, biology students, and so on, or it could be subgroups of sports athletes like basketball players, football players, and tennis players. Let's use an example of known ethnic strata. Suppose a researcher wanted a representative sample on the basis of ethnicity from the state of Texas. The procedure for stratified random sampling is that you would first find the composition of different subgroups in Texas. So Texas might be comprised primarily of Caucasian and white individuals at 45.3%, Latinx or people of Hispanic origins at 37.6%, and African Americans or people of African origin at 11.8%, and so on. You would then divide your sampling frame by ethnicity and then randomly select using either simple random sampling or systematic sampling from each strata using the proportions to create a sample. To use a crude example, if you needed 1,000 participants, you would randomly select 453 participants from the Caucasian white subgroup, 118 participants from the African American African origin subgroup, and 376 participants from the Latinx Hispanic origin subgroup, and so on. The last method of random sampling we'll discuss here is cluster sampling. Researchers who use cluster sampling understand that, like in stratified random sampling, the population is comprised of subgroups. In cluster sampling, unlike stratified sampling, the smaller groups or clusters are either naturally occurring, like in geographical regions, or administratively created, like in school districts. Pollsters use cluster sampling all the time in determining where people's votes lie on specific candidates. They randomly select different polling districts in a state, and from there they select different individuals using one of the random sampling procedures discussed earlier. I myself often use cluster sampling in my research projects on bullying. I first randomly sample from different school districts in Texas. Then I randomly select schools from within those districts, and then I randomly select students from within those schools. You can see how I started with an administratively created cluster like school districts in a state and worked down in levels of specificity to reach a sample. That's the basis of cluster sampling. That's all I have for Module 7. Can you believe how fast this semester is going? We're already past the 1/3 point and moving quickly toward the mid-semester. Please don't forget to read the textbook pages listed in the syllabus and complete the Module 7 quiz. Our video presentation was a little bit shorter than usual, but we still covered a lot of important information. We started this video by talking about what populations are and how they relate to samples. Specifically, we talked about the process that we go through in drawing samples from populations for the purposes of estimating the population level parameters using the statistics available at the sample level. We then moved on to the differences between random and non-random sampling. We finished our discussion by talking about the advantages and disadvantages of specific random sampling methods. As usual, please don't hesitate to contact me if any questions come up. I'll see you back here for part 2 of sampling, where we'll focus on non-random sampling methods. Have a great remainder of your week. Peace out.